Hey everyone, we are here for our last session. We have Mikira, CEO and founder of Hashcloak. She'll be doing a talk around challenges around access privacy in DeFi. And when she starts talking, can you guys just confirm in the chat that you can hear her? And we'll be off to the races.
Hello everyone. As Shinju said, I'm Mikira. I run Hashcloak, a consultancy, an R&D shop in Toronto. So today I'll talk about DeFi access privacy, challenges around access privacy in DeFi. I guess throughout the talk you'll kind of learn what that is. A lot of this stuff is a work in progress, so we're also seeking feedback around these ideas. And if you are interested, you can always just contact us directly. There's ways at the end of the presentation. So a little bit of motivation. Right now, most public blockchains are just pseudononymous. So you have some sort of on-chain identifier that isn't necessarily linked to your personal identity, but through the other methods, you can sort of create identities. As well, there's nothing by default that sort of hides your network level identities with your on-chain network identities. And even more, there's nothing that really hides how you interact with Ethereum. And so tonight, or I guess wherever you are, we'll be focusing on the third point, on how users interact with Ethereum. So what is access privacy? So it's like the set of information that reveals your access patterns to outside people. So this usually pertains to wallet level interactions, whether that be a wallet in your browser or on your cell phone, or like scripts that you write. So it's pretty much like a user-facing issue. So we've covered the state of access privacy in Ethereum, and sort of what this means for certain segments of DeFi users. We won't be covering on-chain privacy techniques. I'm pretty sure throughout the zkp-privacy summit, you've gotten a lot of information about that. So this is a general picture of what a peer-to-peer blockchain network looks like. It's taken from the paper Blockchain Access Privacy by Cont'd et al. And every chain roughly has a set of pull clients, like clients. Some of these pull clients might be miners. Some of them are just full nodes, trying to ensure the security of the network. Users submit transactions to these nodes for inclusion into the chain, and then they wait for an update to their balances, and they fetch. This is like implicit in your application, but no, the client fetches information and then it updates on your wallet. So first, I go through a little bit about Ethereum and how it works. Just a very high level overview. So Ethereum uses DevPTP, which is a custom-made protocol for finding and connecting to nodes in the Ethereum peer-to-peer network. It has a series of different protocols. RLPX, which defines a serialization method. Node discovery, which is for discovering other nodes. The Ethereum wire protocol defines all the messages. And then the Light Ethereum subprotocol defines how light clients should act. These are not all the protocols for DevPTP, but these are the ones that are currently mostly in use. So first we'll cover publishing to Ethereum. So the sort of top left focus one announcing transaction part. We'll briefly go through how that works. So users in Ethereum publish transactions to DevPTP nodes through gossiping. So pretty much they take a subset of so once a node sends a transaction over to a node that they're connected to, then that node will take a subset of their closest peers and then send the transaction over, and then it keeps on doing this process. So that's what we mean by gossip. These nodes will keep on doing this process in order to ensure that they get all possible transactions they can amongst themselves, and then they'll relay it to minor nodes. And then from these, this sort of optimization that's from a recent version of the Ethereum subprotocol, where each node has its own pool of transactions, and then they will try to sort of optimize for what's not in their local pool. And then they'll propagate. They'll also try to guess sort of the transactions that are in other nodes' pool and propagate those relevant transactions to them. Kind of, it gets immediately obvious how this doesn't really preserve your privacy. If you had a few listener nodes run on a network, of course you would need like quite a few of them that were just listening and like recording where the transactions were coming from. Then you'd be able to sort of trace back the source of the message. There's a lot of theory around this. I guess if you've been following COVID-19 epidemiology, it sort of follows like the flow and propagation of viruses. So some of the techniques can be used for finding the source of a transaction in a gossip-based peer-to-peer network. And then it's even easier with like this optimization where you try to guess the most relevant transaction to your nearest peer. So you don't send all your messages over, but just a subset. And yeah, this has some privacy issues in that anybody can sort of determine who originated the transaction. And then now we'll go through fetching information from Ethereum. So fetching is most relevant for sort of syncing to the Ethereum chain. Say you want to have a full node, you want to ensure that you're like on the right chain. But the most relevant to us is LES, since that's mainly user facing. LES uses a series of data structures. One is called the Canonical Hash Tree. It stores like the minimal amount of information that a light client needs to know in order to verify that it's on the right chain. So it stores a simple mapping of block number to block hash and the total difficulty, and then it verifies this on your wallet. So these canonical hash trees are generated by LES servers. So these LES servers are just either full nodes on the chain or miners that like designate themselves as LES servers. This is not enabled by default, I believe, in Ethereum. And they do this every like roughly 30,000 blocks. And then for each of these blocks, try to ensure that they're not reorged. So roughly after over 2,000 transactions, confirmations, sorry. The other data structure that LES uses is BloomBits. And then this is for searching logs on chain. And logs are heavily used by smart contracts for storing information that's relevant to wallets, and the application itself. And so this reveals a lot of information about what you're trying to get. And so BloomBits does this. Oh, it's a typo. Well, anyway, so yeah, BloomBits helps. It helps make it easier to retrieve logs that are relevant for you. Uses Bloom filters, and it's compressed even further to save even more space. So like I mentioned just now, through the use of logs, you can easily sort of determine what application you're trying to use or you're using. And furthermore, oftentimes Ethereum users are using Infura or other third-party services. And so they have detailed information about sort of whether you're using MetaMask or a mobile wallet. Since they don't use any sort of IP level, network level protection, then you can get a rough geographical location of where the user is, and can determine what kind of queries you make. And so this has a few implications for your favorite DeFi application. At least when you think about it in terms of the everyday usage, as opposed to yes, number go up. So when you combine all this information about like users, then you get like a very sort of granular view of your activity on chain and off chain as well. So I'll go into more detail about that. So first, for regular users, you probably already have sort of a very detailed profile across different websites, depending on how careful you are with, I guess, your online activity. And then this can be sort of combined potentially with, your Web3 sort of information. And then this, I guess, just adds to the current like sweep of information to your profile. I guess in the Web3 world, people don't really think about this much, but you ideally want sort of have a separation of these, but I guess it's not really easy to do. And then I guess for like major or like bigger users, this isn't like information that you usually get in traditional markets. You can easily infer some of these due to like regulations and I guess trading patterns activities. But this is much easier to get on chain, especially when you take into account like the dark forest that is beginning a lot of popularity recently. We can also get other information such as devices and the OS being used, which is more information than usual. So it does pose like a very interesting problem for like enterprises as well, and other like larger users. And I guess to add on to the previous slide, if you're like one of these enterprises, then due to the open nature of sort of the DeFi ecosystem right now, then it's very easy for your competitors to like know what you're thinking about. Maybe leaks alpha, I guess, but yeah. So I want to discuss very briefly what we're currently working on at Hashcloak. So I tweeted this out, I guess, March 21st. And I got like a lot of good feedbacks. We've been working on this a little bit. If you're interested in working on this, you can like contact us as well. We're also looking for a collaboration. So first, we're working on the mixnet. This is mostly for users who just want to transact and hide their network level information. It's currently just a one-way mixnet. So that means that you will just send transactions through it, and that's it. Right now, we support all ETH forks, their testnets, and Binance Chain. This is mostly ideal for just sending over regular transactions, since the latencies tend to be quite high. So if you're actually using like DeFi applications, this isn't ideal. We are working on other things that would be more ideal for DeFi related application. And then Baryon, this is a like very work in progress. And this is for implementing private information retrieval. So ideally, Baryon and Meson together would get like a two-way mixnet. And the other way would be to retrieve data from one of the supporting chains using private information retrieval, and then this would be done privately through the mixnet. The requests would be done privately through the mixnet, and then this would hide as much information as possible to an outside adversary about sort of what you're querying for and who's doing the queries as well. So to end this talk, I'll leave the audience with a few open research questions. So I mentioned that we were working on like a mixnet and some other methods, but in order to better sort of get potentially like, a thing that something that can be deployed much faster, it'd be nice to be able to take advantage of the gossiping structure of Ethereum's DevPTP protocol and then leverage that to sort of create overlays that can help with protecting network level information. An example of this is Dandelion++. One of the sort of driving factors for the design of that is that it takes advantage of how Bitcoin works and then provides a very simple to implement and to understand protocol for improving the network level privacy of Bitcoin users. The second point here is related to private information retrieval protocols. So this one is a bit more esoteric, but and a lot of like construction of these, it pretty much considers like fixed sets of clients and fixed sets of servers. It doesn't really consider sort of servers coming in and out, which in a blockchain network, that's always what's happening. Nodes are unavailable sometimes, they're Byzantine. So some private information retrieval protocols do take into account Byzantine behavior, but not like sort of other things. Some more. So right now, all the DeFi applications are just considered, when they're being built, they just consider sort of the economics and sort of how efficient they are to run, but don't really take into account sort of any other privacy portions. So how can we build better privacy preserving DeFi applications? And then the last one is mainly pertaining to UX. So what are the appropriate trade-offs between convenience, efficiency, and privacy? So as I alluded to earlier, when you add privacy to certain layers, it does add latency or makes it a little bit more convenient. So what are the good, sets of trade-offs to make for providing a good user experience to different user profiles? So that's the end of the talk. So you can get me on Twitter at badcryptobitch. My email is mikira@hashcloak.com. And then I made this really long list. It hasn't been updated in a year, but I guess you can make a PR if you want. So, yeah, that's it. Any questions, I guess?
All right, guys, if you have questions, can you drop them in the chat or in the ask a question section?
Or you can send an email or a DM on Twitter. I should have added Telegram. I'm just Mikira on Telegram. It's just my first name. Is there a need to incentivize a PR based? So in order for someone to want to run one, like say like some random person, so the question is there a need to incentivize a PR-based info retrieval system? So if you want like just some random person running it, perhaps, because there's a lot of storage, and like you have to expend a lot of resources to like run one of these servers for sure. However, if you want to delegate it out to sort of like, and if you're like service, you can probably do that as well. So I guess this is sort of like a, I guess, open question as well, whether you actually need like a incentivization system for this. Yeah, I think there's a lot of answers.
Cool. I think there was one other question around your thoughts around Zcoins getting wrapped.
Zcoin is getting around.
I don't know, like privacy coins getting wrapped, maybe.
I know. I see this entire section about RenPM.
All right. Are there any other questions that you see?
No.
All right, perfect. Cool. Do you have any closing thoughts?
No. That's late.
Awesome. Well, thank you guys so much for sticking with us for this entire day. We will be closing out the summit and we'll be kicking off Liquidity 2020 again tomorrow, last day. So join us at 9 a.m. Thanks so much. This is a really great talk. Bye.